TACC stands for the Texas Advanced Computing Center. TACC's mission is to enable discoveries that advance society and science through the application of advanced computing technologies. We're a leading academic center in terms of the national community. We support National Science Foundation researchers, plus UT Austin, UT System, and researchers across the state. Stampede is really our premier high-performance computing system. Inside each one of the Dell PowerEdge servers is 2 Intel Xeon processors, plus an Intel Xeon Phi processor. These components allow us to get the peak performance of 10 petaflops in the system, and that's what really allows us to support thousands of researchers running simulations and research too complex to be done through their normal desktop environments. Dell and Intel have been established for a long time in high-performance computing. We're leveraging all the technologies that are out there right now to support our users, and some of the new Dell server and hardware that we're deploying is very dense. We can get up to 60 to 70 servers in a single rack and still operate within our machine room environments. We've proposed a new system to augment what we already have on Stampede, a Knights Landing system, all interconnected with Dell networking H-series switches that leverage the Omni-Path architecture that Intel is producing. We have some initial engineering samples of the Omni-Path architecture in-house, and we were quite impressed with how easy it was just to cable them up, install the software. The tools just worked right out of the box. And in fact, we started getting performance that was beyond our initial expectations, almost 2x the performance of the existing InfiniBand interconnects that we operate on Stampede. One of the key aspects of the Omni-Path architecture is the fact that the previous InfiniBand technology has used 36 ports in a single switch. Whereas the new Intel Omni-Path hardware will use 48 ports in a single switch. What this allows us to do is build larger fabrics with fewer switches, and it also reduces the latency of the very large-scale systems. One of the challenges we have with the current Stampede architecture is that we do see congestion in the fabric when there's lots of jobs running on the system. The Omni-Path traffic flow optimization can ensure that higher priority traffic makes it through the system and doesn't get slowed down so that people can maintain performance and get their simulation work done when needed. The relationship with Dell and Intel has been fantastic. They've obviously helped us with increasing the capability of the systems. We have researchers on our system looking for cures for cancer, severe weather forecasting like tracking tornadoes, being able to see all these advances in science and supporting them through the operating of the hardware to make it available to them. That's really the exciting role of being here at TACC.